The topic now is percentage error. This is a very important topic that you must expect in WAEC. Let's look at the objective. I expect that at the end of this lesson, you should be able to find the error from wrong measurement. Error from wrong measurement. Error from wrong measurement. You should be able to find the actual measurement and also to find the percentage error of any measurement. Error is different from percentage error. Percentage error is when the error is based on percentage. Let's look at some stated degree of accuracy and error in measurement. For example, when you measure anything, there is possibility of error, either due to the measuring instrument or the thing you are measuring or the way you measure it. So people, when they are measuring things, see that their hand will be shaking. Some people, the instrument they use might not be accurate enough. For example, these are things you need to note. Anything measured in meter, there's possibility of 0.5 error. When you measure anything to the nearest 10, there's possibility of 5. Nearest 100 has an error of 50. Nearest 1000 has an error of 500. And the nearest tenth has an error of 0.05. And to the nearest 100 has an error of 0.005. Also, to the nearest 1000, it has an error of 0.0005. These are ones you need to know offhand. Then look at this wonderful example. For example, this can come out in objective. It said the length of a wooden box is 60 meters. Then find the percentage error if the length is measured to the nearest meter, the nearest 10 meter. So the error, something that is measured to the nearest meter, I told you the error is 0.5, that is half divided by 1. Then the formula for percentage error is error over actual measurement. E there means error. AM is actual measurement times 100 over 1. So the error here is 0.5 times the actual measurement, which is 60, then times 100 over 1. And when you do that, you have 0.833. Now the second example here, he said the length of a wire is 6.65 cm and a student measure it to be 6.35 cm. What is the percentage error to 1 decimal place? The length of the wire is 6.65 cm and the student measure it to be 6.35. What is the percentage error to 1 decimal place? Now, the error, first of all, is actual measurement minus the wrong measurement. The actual measurement is 6.65 and the wrong measurement by the student is 6.35. So when you subtract that, you get 0.3. The percentage error, now remember, is error over actual measurement times 100 over 1. Now, when you do that, you now have 30 over 6.65, which equals to 4.451. And this correct to the nearest one decimal place will give you 4.5%. Now, let's also look at the third example. Is a little bit different. This you can expect in section A. The first 5 objectives can come. The first 5 compulsory question. This is more than objective, unless maybe in JAM. So you can expect this in theory in WAEC or NECO. Is that the percentage error of the measurement of a pole is 6%. If the measurement was 35 meters, find the actual length of the pole. Here the percentage error is given, and the error is 35. So find the actual length. So somebody measured the length of a pole wrongly and got 35 meters. And the percentage error is 6%. So what is the actual measurement of the pole? So wrong measurement is 35 meters. So the actual measurement is what we are looking for. And the error is 6%. Sorry, the percentage error is 6%. So we don't know the error. So percentage error is error over actual measurement times 100 over 1. So error now the percentage error is 6. To express it in percentage, that is 6 over 100 times actual measurement minus 35. Because remember that error is actual measurement minus wrong measurement. So that error there, instead of putting error over actual measurement now, error is actual measurement minus wrong measurement. So that is why E is being replaced by actual measurement minus 35 over actual measurement. So when you do cross multiplication, you now have 6 AM is equal to 100 bracket AM minus 35. And when you expand that, you have 6 AM is equal to 100 AM minus 3,500 when you expand that. And when you collect item, you have 3,500 is equal to 100 AM minus 6 AM. So 3,500 now is equal to 94 AM. Then AM now is equal to 3,500 divided by 94. So actual measurement now, when you divide that, is 37.25 to 3 significant figure. You correct that to 3 significant figure, you have 37.2. So if you like, if you look for the error, remember that actual measurement minus wrong measurement gives you the error. So the error is 2.2 meters. So we have another similar example in number 4. You see, the length and breadth of a rectangle were mistakenly measured as 40 cm by 35 cm instead of 42.5 cm by 34.2 cm. Find the percentage error in area and also in perimeter. You see, the rectangle, the actual length and breadth of the rectangle are 42.5 cm by 34.2 cm. But somebody mistakenly measured it as 40 cm by 35 cm. So the actual length is 42.5 cm and the wrong length is 40 cm. The actual breadth is 34.2 cm while the wrong breadth is 35 cm. Now, what is the area? We're looking for percentage error in the area, percentage error in the perimeter. First of all, you must know the area of a rectangle and also the formula for calculating the perimeter of a rectangle. So let's look at A now. A, wrong measurement of in the area. These are the wrong dimension. 40 times 35 will give you 1400 cm square. Then the actual length, the actual measurement, that is the actual area now. If we were to use the actual measurement for the 2.5 times 34.2, and that will give us 1452.5 cm square. So what is now the error in the area? That is the actual area minus the wrong area. And that will give us 53.5 cm. So therefore, going back to the formula, percentage error in area, percentage error in area is error over actual area times 100 over 1. And that will give you 53.5 over 1453.5 times 100 over 1. And that gives us 3.6808. And to three significant figure, give you 3.68. So for the perimeter, wrong measurement. Remember that perimeter of a rectangle is 2 bracket length plus breadth. Perimeter of a rectangle is 2 bracket length plus breadth. And that will give you 2 bracket 40 plus 35, which is 150 cm. Using the wrong measurement. Then the actual measurement perimeter is 2 brackets for the 2.2 plus 34.2, and when you do that, you now have 153.4. So the error in perimeter is 153.5 minus 150, and that will give you 3.4. Going back to the formula of percentage error in perimeter is what? 3.4 over 153.5 times 100 over 1. And that will give you 2.216. And to three significant figure will give you 2.22%. So I want you now to do this classwork. What is the percentage error in an area of a lawn that is actually 750 meters square and is found to be 690 meters square? What is the percentage error in an area of a lawn that is actually 750 meters square and found to be 690 meters square? Then also do this assignment. A square is 10 meters. A square is 10 cm by 10 cm, and the student measure a side of the square as 9.9 cm by 9.9 cm, and use the measurement to calculate the area of the square. Find the percentage error in length of the side and area of the square. Use the last example to do this. We'll meet in the next class.